Okay, we're going to take a look at the four main types of weather fronts. So again, a front is a transition between two air masses, and those air masses have different densities because they have different air pressure, temperature, and other characteristics. So the front is just really a boundary. Think of it as a boundary. And with all this, remember, cold air is more dense than warm air. So if it's more dense, it's going to want to hang at the bottom. If you think back to the week 6 atmosphere lesson when we did the density column and they poured all the different materials in the graduated cylinder and made a big tower, those things that were at the bottom were more dense, so they like to stay there. That's how cold air behaves. I can't get rid of this little box, so we're going to roll with it. First is a warm front. Now this interactive lets me drag. So behind this faded white area is the cold air mass. The front is this blue line here on the surface. And remember, an air bubble, think of it going up into the atmosphere. So think of this as being a big bubble of air over you. So if you're standing right here, right now you're in the warm front, or you're in the warm air mass. It's warmer air. When this cooler air moves in, the front is the edge and the boundary. So as I drag this front forward and push the cold air mass, you notice that that warm air goes up and over, it's less dense, and we see a rising tower of clouds. So let's watch that again. When it first starts, the warm air is going to rise, and it's going to cool, and it's going to condense. So what we're seeing now is the water vapor that was in that warm air has now cooled and condensed and formed little tiny droplets, and big areas of tiny water droplets are called clouds. Taller and taller clouds, warm air gets forced upward. So looking at the shape of this front, this is a very drastic push up of warm air. The shape of this front is what gives it this very distinct weather pattern. Along cold fronts, we see severe thunderstorms, those tall cumulonimbus clouds, and that's usually where on the radar, if you look and see how the storm's moving in, you basically see a strip of storms going up the eastern seaboard. So that's the cold front, a very drastic change. Back to our menu, and we're going to do the warm front now. Now this one looks a little bit different. The cold air is still going to want to be on the bottom. Warm air, just because it's a little bit lighter, less dense, it flows slowly over top of the cold air. It doesn't have a lot of power or push. So if you notice, instead of a very sharp wedge like the cold air when it was moving in, this warm air is going to gradually move up and over the cold air. So we're going to see different weather. So we're going to let our warm air mass move. We're going to try. There we go. Start to see some low clouds, gradual change, higher clouds, and some rain. It's not as sharp. You don't have severe storms here usually. You just have a change in weather, and what's left over afterwards, when we had cold air at the beginning, now we're left with some warmer weather, because what comes behind a warm front is a warmer air mass. Let's go back and do occluded front. This one's kind of hard to understand, but this visual is really good. So, with an occluded front, got a lot going on here. So first, this pocket of air in here where I'm drawing with my mouse, this is warm air. Warmer air, I should say. The light white area is the boundary, that's our front. So you see this purple line, and what's going to happen is, basically on the right half of the screen is a warm front, on the left half of the screen is a cold front. Think of it as a cold front catching up to a warm front, wedging warm air up between two cold air masses. So if you're standing here, you're experiencing the warm front. As the cold front catches up, because it's moving a little more quickly, it's got a lot of force because it's cold and dense, you basically are stuck in between two pockets of cooler air while the warm air gets pushed upward, and that leads to a lot of precipitation. So let's watch this one. Warm air forced upward. Now on the surface it's just cold air. And this causes basically a combination. You get a few days of heavy rain with an occluded front. And this happens sometimes. Warm air or warm fronts don't move as quickly as cold fronts, so sometimes those cold fronts catch up, and it's called occluded. Think of it as stuck. That warm air gets stuck. And basically this cold air mass has to power through and overcome all of this warm air and cold air ahead of it, and once it clears, you're good to go. So occluded fronts sometimes take a little bit more time. Back to the last one is stationary front. You can tell by the coloring that this is going to be kind of a combination or a meeting of two different types of air. This time, instead of one moving in and pushing the other away, they're moving toward each other. And there isn't really anything to do on the interactive. I'm clicking and trying to drag, clicking and trying to drag, and it's just a battle. I'm going to let my mouse go. You can see it's kind of a push back and forth. What usually happens is the cold air usually wins out. It usually has a little bit more force because it's more dense and pushes a little bit more. But with a stationary front, anytime you see those alternating blue triangles and red semicircles on the weather map, you know that basically those two are battling it out. And one's going to overcome one of the other, and you're going to end up with a few days of rain. Again, this is because the moisture that was in the air on the surface gets pushed up, it cools, it loses its energy, it forms clouds and forms cloud droplets, and then it's going to start to fall in the form of rain. So stationary fronts also bring usually a few days of some light rain. And that's the 4 different types of weather fronts. So we encourage you to go give that interactive a try and play around with it a little bit. It's a really good visual of how these air masses interact in the boundaries that we call fronts.